I'm going to graph both of these functions and compare them, try and get some kind of an understanding here. So here's my two functions. Before I graph these things, there's one thing you have to make sure of when you're graphing a trigonometric function in a calculus class. What is it? Yeah, you have to be in radian mode. So if you're not in radian mode, hit the mode key and change that up. Let's also change our window. Since I really only care about the window or the function in this interval, I might as well just use that interval. Negative 3 pi over 2 to 3 pi over 2. So let's change our window up that way. Negative 3 pi divided by 2 to 3 pi over 2. 3 pi divided by 2. Now, as far as the rest of this, if I wanted to be a little bit lazy, I could just let the calculator do the work for me in terms of setting up the y coordinates. For the moment, I let x scale equal 1, but I'm going to go back and change that. But if I wanted to be lazy and let the calculator do the work, I would hit zoom 0. And that'll make the calculator, let the calculator fit everything, and yeah, it looks like this. But there's a couple things that I might want to clean up here. Sometimes it bothers me that the calculator, or this function, just barely fits. I want a little wiggle room above and below here.
Put in the y equals.
Yeah, so I'll widen this. Maybe negative 1.2 to 1.2. Just makes me a little bit nervous.
Would you put in the y equals? Could you show that again? You put cosine or the
So
cosine?
looking back at my functions, those are my functions. Take note of the fact that the blue one is my cosine, the red one is my minus sine. So there we go, there's the blue one. But this still isn't as helpful as it could be because, I mean, for instance, this graph crosses the x-axis a little bit to the left of negative 3. If you want to do yourself a favor, go back to table set and let's change the tick marks. Put them in units of, say, pi over 2 or pi. Do it in units of pi divided by 2, then the tick marks are going to show up at useful places for you on the x-axis.
So does this need to be in radian mode for it to work?
Yes.
Okay.
So this graph crosses the x-axis, the blue one, at pi over 2. And then comes back again at 3 pi over 2, and so on. So these tick marks are now where interesting things are going to happen. Now if you wanted to find a maximum point, you can do that. You hit the second key, and the calc key says, what do you want? You want to find a maximum point? You want to find a minimum point? Here you go. So let's find a maximum point, 4. And you know what? Well, maybe let me change it up. Let's find a minimum point because it's just going to give me a 0 there. So second, and then calc. Let's find a minimum point. So I'm trying to find a minimum point for this graph. So let me just kind of cursor near it because it's going to want to guess about where that minimum is. So you want to pick something near it. So I stopped here. You don't have to stop at exactly the same point. And I'm going to press enter. And now I need to give it some point to the right of where I'm going to try and find a minimum, which, I don't know, you can cursor over here like that, and that's fine. Or you can just type in a number, like, say, 3.5. And that's the right boundary. You just start typing in numbers and it'll peer it up. It's going to look for a minimum point now in this interval between this point here and this point here. You see the arrows up there showing you where it's looking for a minimum point. And it says, well, what's your initial guess? Just press enter. Let your calculator do the work. And there you go. Now, hopefully you recognize that value as really being the first few digits of pi. That's your minimum point. So nice. You can do likewise with a maximum point. The only reason I chose not to do it with the maximum point is because that would give me a 0. You could also find the points of intersection with the x-axis. So if you hit the up arrow key, that puts me on the red graph. And if I was someplace on the red graph, And let's see. If I was someplace on the red graph, I wanted to find where the graph crossed, say, the x-axis, because that's where my derivative is going to be 0, I can find that as well. Second, calc. This time I want to find a 0. So it's going to do the same game that you did last time. I want it on the red graph. It's going to ask for a left bound, something to the left of where your graph crosses the x-axis. So you get there, you press enter, move your cursor to the right, press enter again, that's the right bound, press enter one more time, and now it finds where the graph crosses the x-axis. So again, that's the decimal equivalent of pi. So your graphing calculator can do a lot of these things. It's just not nearly as neat and efficient as, say, Desmos. I mean, Desmos, you can just click on these numbers and it'll find them. It's great. But not everyone's going to be letting you use Desmos.
My other calc professor did.
So comments or questions on any of those functions on the graphing calculator? All right, let me.
Thank you for showing that.
Yeah, you're welcome.